Hello, welcome to the course on microwave and antennas. In this lecture, we will learn about klystron oscillator design. Let us consider the microwave tube. Say we feed this tube with electrons from one side and say the other side is closed. So what happens is that the electrons based on the velocity that is fed and the collisions in the path, it travels certain distance and then loses energy mostly as heat. Now say we add an electrode. That is a plate at the end of the tube which has negative polarity. We know that electrons are also negatively charged. So now what happens is that electrons don't even go closer to the end of the tube because of reflection from the electrode. Those electrons return and lose energy on the return path. Now say we add an acceleration grid. Which has positive polarity. So what happens now is that the electrons coming from the electron gun are pulled by this grid. But since acceleration grid is not a plate but a grid, so what happens is that many electrons are pulled towards the grid with great force and pass through the grid. Towards the electrode on the other side. Few electrons may hit the grid and they will lose energy. So ignore these electrons. Now the electrons which have crossed the grid and reached the other side reflect due to negative polarity of the electrode. And these electrons are again pulled by the acceleration grid or the anode. Again, some electrons pass through this grid and some get absorbed and the energy is dissipated as heat. Continuing our discussion, whatever the electrons pass through the acceleration grid on return path again gets reflected due to negative polarity of the electron gun. Thus, these electrons create an oscillating effect. Inside the tube. So this tube has created an oscillating effect, but these oscillations are not useful due to two reasons. One, the oscillations are not collected to be used as useful signal. These oscillations are random That is, the oscillating frequency is not controlled. So, let us modify the tube. Let us add cavity and additional power supply. Why should we add the cavity? 1. It will create desired oscillations. Number 2. Cavity is used to collect the microwave oscillations or the energy. We have seen this image before. This is a 2D donut shaped structure with a tube in between. Let us understand the significance of this cavity. Cavity is a key element in the klystron oscillator. Let us recall the electrical oscillator or the tank circuit. Here, cavity is like a tank circuit. The loop, what you see, is like an inductor L, and the opening is like a capacitor C, which has two parallel plates separated by an air gap. Hence, this is called as a mechanical oscillator, and this is an electrical oscillator. You can change the cavity dimensions and the frequency of oscillation will change. This is similar to how you can change L and C values to create resonance in a particular circuit to achieve a particular frequency. Remember that we have to add power supply to the cavity, else the oscillations will die down. This is similar to a tank circuit which requires power supply to be added, else as time progresses the oscillations will die down because without power supply there is no fuel or energy for the oscillations to sustain.